human brain is capable of many things. One particular area is the cerebellum, the most primitive part of the brain, but it contains more neurons than the brain itself due to excessive folding. The cerebellum is most important for motor control and motor learning. There are 3 pathways in the cerebellum. Sarah approaches a log. She decides to use her training as a hurdler to jump over it. The functional division involved in calling on her motor experience is the cerebrocerebellum pathway. The cerebrocerebellum, or neocerebellum, is the most recently developed functional division of the cerebellum and is responsible for planning and modifying the motor output to muscles, muscle coordination, and muscle tone. The primary motor cortex sends the information that Sarah wants to jump over the log to the cerebellum. This message is sent via fibers that go through the internal capsule to the pontine nuclei. From this nucleus, the fibers decussate as pontocerebellar fibers through the middle cerebellar peduncle, extending into and synapsing in the posterior lobe of the cerebellum. Cerebellar cortex fibers project to the dentate nucleus deep in the cerebellum. In the cerebellum, the message is processed and validated, telling Sarah that she can in fact make the jump, based on her previous experience as a hurdler. Fibers exit the cerebellum through the superior cerebellar peduncle. Most of these fibers decussate at the midbrain and synapse at the ventrolateral nucleus of the thalamus. However, some synapse at the red nucleus. Fibers from here go to the primary motor cortex, which sends fibers down the corticospinal tract. Most descend contralaterally and some ipsilaterally. Fibers also extend from the red nucleus to form the rubrospinal tract. Sarah is able to run away from the zombie successfully because her gait is very smooth and she has impeccable posture and a keen ability to dodge incoming obstacles. She gets this from her spinocerebellum. She receives proprioceptive information from proprioceptors which ascend the spinal cord through the dorsal and ventral spinocerebellar tracts, running in the lateral funiculus of the white matter. The dorsal one carries information of the muscle in space and the muscle tone, which enter the cerebellum through the inferior cerebellar peduncles. The ventral one carries information pertaining to the motor command that the muscles have received when moving. It decussates in the lateral funiculus of the spinal cord and travels to the midbrain where it decussates again. This goes through the superior cerebellar peduncle. This information goes to the anterior lobe and vermis of the cerebellum. This will process information and go to the deep nuclei of the cerebellum. Movement originates in the interposed nuclei, the globose and emboliform nuclei, which project to the red nucleus on the contralateral side and then to the rubrospinal tract. Other fibers project to the reticular formation in the brainstem and go through the reticulospinal tract. The reticulospinal tract can be bilateral to coordinate movement on both sides of the body. It controls and coordinates skeletal muscle movement through adjusting force and direction. Sarah is very thankful for her spinocerebellum, which allows her to run with a smooth gait and correct movement, allowing her to dodge obstacles. However, lesions can occur in this pathway with serious implications like tremors, slowness of motion, muscle rigidity, and an ataxic gait. This poor zombie here has a lesion affecting his spinocerebellar tract, hence he has an ataxic gait. Sarah has a functioning vestibulocerebellar tract. Not only can she balance without the use of visual input, she also has vestibulo-ocular reflexes. Because Sarah has an exam, she needs to study. At least with the use of her vestibulocerebellar tract, she can read her textbook while still running away from the zombie. Input from the inner ear gives information on the movement of the head and body. This travels to the vestibular nucleus in the brainstem and then to the cerebellum via the inferior cerebellar peduncles. It goes to the flocculonodular lobe and the lingula of the cerebellum and is processed in the fastigial nucleus. Information is then sent to the medial and lateral vestibular nuclei. The medial vestibular nucleus sends information through cranial nerves 3, 4, and 6 to the eyes for ocular stability. The lateral vestibular nucleus sends information via the vestibulospinal and reticulospinal tracts to the spinal cord for balance.